Okay, so give me an example of an algebra of an inequality that you've done before.
1 is less than 2.
Good. Okay. Now, here's like a very sort of fundamental way of looking at inequalities, which seems obvious, but is very important. Right? Yeah, like this guy's the bigger mouth, and he's. Do you guys do that? The cake thing or whatever? Right? Yeah. And you can add some teeth as well if you want. There you go. Okay, sweet. Now, here's two basic ideas. If we add the same number to both sides, so let's say c is some integer, then this inequality remains true. Okay, so if you add the same number to both sides, this remains true, and this works whether c is positive or negative. Okay. The other thing to consider is that if we multiply by the same number, what do we know is true? So if I multiply by c now, does the inequality maintain? When doesn't it? Right. So this inequality holds true where c is greater than 0. Okay? So this is always true?
C squared.
Yeah, so if you want to maintain it, you multiply by c squared, right? Exactly. Okay, so this is still true. Okay? Now, think about with an inequality, right? It's really easy to compare with numbers, but it's not so easy when you're trying to show that A is less than B, for example, right? Think about it in a different way you can express this. How can you actually know if two numbers or two expressions are greater than each other? Like if you take 2 and 1, yeah, we know 2 is bigger than 1, but is there another way we can kind of express that? Like, how can we know if two numbers are bigger than each other or not? It involves like an operation, if you want to think about it. Maths. Think back to primary school, like when you try to do something with numbers, like.
Tried to add them.
Well, what if you tried to subtract them, right? What happens when you try to subtract a smaller one and a bigger one?
Smaller one. Like
Yeah, if you tried to do like.
from a small one, then we can take one.
Right, so like this is something that in primary school we used to say, oh, you can't really do this, right?
Oh, wait.
So.
It might be possible.
Good. Okay, exactly right. So think about like rearranging this expression in another way. If we just rearrange this to b minus a is greater than 0, okay, that's another way that we can show that. Would you agree? Yeah. This is probably the most fundamental idea and the most common way that we can prove a lot of these algebraic inequalities, because it's not easy to identify immediately that two expressions are bigger than each other, but it's a lot easier to identify if the subtraction is greater than 0. Okay, I'll show you a few examples of that. So here are some inequality strategies that I need you to write down. So the first and probably most common way we'll start off with is to put everything to one side. And what I mean by that is we're doing exactly what we did there. We do the left-hand side minus the right-hand side, or the right-hand side minus the left-hand side. Depends on like how the inequality is written, but that's like an example of that. Now think about how do we know when things are bigger than 0, right? A big thing that we looked at when we were doing like functions and stuff like that was that squares can't be negative. So if we can get to a situation where we have like some sort of square, we can really show that that's greater than 0, or greater than or equal to 0 at least, yeah. And 3 other ways. You can start with a known result. You can use a combination of inequalities. And from like the previous as well, you can use a proof by contradiction. So kind of tying in all these different methods. Okay, 5 different ways. We're going to focus on the first 2 today, and then we'll see how far we get.